Hello and welcome to Design Patterns in C. My name is Ahmed Yusri and this is session number 1. During this session, we are going to discuss how we could implement the finite state machine. Our session will be divided into 3 parts. The first part will be an example of a system that we need to implement. The second part will be a description of the state pattern, and this is the pattern that we are going to use. And the third part will be an implementation of this pattern in C. So let's start with the first part. Our system consists of 4 LEDs and 2 buttons. If the user presses button number 1, then the third LED is going to blink for 3 times, indicating that we have entered the left state. Then the 3 LEDs is going to blink from LED number 2 to LED number 0. If the user presses button number 2, then the third LED is going to blink for 6 times, and then the 3 LEDs is going to blink from LED number 0 to LED number 2. If we press the same button again, then the third LED is going to blink for 12 times, indicating that we have entered the idle state. So let's see a real example of this system. So we have here 2 buttons and 4 LEDs. If we press button number 1, then the LED is going to blink from left to right. If we press button number 2, then the LED is going in the opposite direction. If we press the same button again, then we are going to the idle state. Also, we have represented our system in a finite state machine. We have 3 states: idle, right sequence, and left sequence. If we are in the idle state and button number 1 is pressed, then we are going to the right sequence. If we are in the right sequence and button number 2 is pressed, then we are going to the left sequence. If we are in the left sequence and button number 2 is pressed, then we are going to the idle state, and so on. Also, I have divided our system into 3 components: the buttons, the FSM, the finite state machine, and the LED. So the buttons is responsible for monitoring the button state, and if we have a button change or a new event, then the buttons will notify the FSM using the new event request. The FSM will process this pending event, and based on the current active state, it will trigger the appropriate sequence using the LED component. The LED component will use the DIO and toggle the correct pin. Our concern for today is how we could implement the FSM or the finite state machine. In a traditional way, we could use the if else or switch case statements, or even we could build a table, and each index of this table will represent a mapping between the state and the transition. In today's session, we are going to discuss another technique called the state pattern. The state pattern is an object-oriented way to implement a state machine. So in the state pattern, we have the context or the interface, and the interface will be responsible to react with the upper layer. So for example, in our case, we have the buttons. If the buttons needs to register a new event, then it will use the public function from the interface, and the interface will delegate this request to the active state. Each state will be represented as an object, so it will implement the concrete class, and this concrete class will just implement all methods that exist in the abstract class. So we have here the state, and this is the abstract class, and each state is represented as a concrete class which implements the all method in the internal state. So for example, if we have a new request or a new event, then the context will use a reference to the active state and uses the new event method to register this event. And the active state will process this event in the cyclic method. Then if we need, for example, to make a transition from the idle state to the right sequence, then we need to exit from the idle state using event exit and enter to the right sequence using method enter or event enter. And then the active state shall return the reference to the new state to the context, so the context will be able to change its internal state to the new one. So now let's see a real example or an implementation of this technique in C. So we have here the header file for the interface, and we have only two functions, the cyclic function, and this function will be responsible to handle the internal state machine, and we have also the register and the new event request, and this function will register the new event. As we described, the interface will just delegate the new event to the current active object, and also the same was the cyclic event, and it will use the returned object to update its current context. Now let's see the abstract class. So we have here the abstract class of the state, and the abstract class will define the mandatory functions for each concrete class. So we have here the enter event, exit event, and the new event method, and also we have the cyclic method. Each concrete class shall implement all the methods that exist in the internal state. So here an example of the idle state. So here is a concrete class for the idle state. So we have the enter, exit, new event, and the cyclic method. So for example, if we need to enter to the idle state, we will use this method, and we will just need to blink the LED for 12 times. If we need to exit from the idle state, then we just need to make sure that all the LEDs are in the off state. And if the interface needs to register a new event, then it just will send an ID of this event, and this in a simple way, if this is event number 2, then we need to reference the right state, otherwise we need to reference the left state. Inside the cyclic method, we need just to check if we have a new event, and if we have a new event, then we need to exit from the current context or the current state and enter to the new event. And also if we jump to the right state, we will see the same way of implementation. We have here the implementation of the concrete class, and also we have an implementation of each method of this concrete class. And also if the interface needs to register a new event, it will use this method. So for example, if the new event is event number 1, then we need to reference the left state, and if this is event otherwise, then we need to jump to the idle state. And the cyclic also will process this pending event, so it will exit from the right state and enter to the new state. And also it will return the new active state to the interface, so the interface will be able to update the new its internal state or its context. And that's it.